In this video we're going to look at conditional expressions in Django, and we're going to see how these allow us to perform if and else logic within our database statements, such as filtering, aggregating and annotating. So a conditional expression will allow us to evaluate some conditions for each row in a table and then return the matching result expression based on those conditions. And we're going to learn about two objects that we can use within the Django ORM, and that's the when object, and these control the logic of the conditions. And we're also going to learn about the case object, and these encapsulate the conditions for the query. So let's get started. I have VS Code open here, and we've extracted the Italian restaurant type here, and we're going to use that within a query, and that's going to be a conditional expression query that we're going to build up with the Django ORM. Now, to start very simply, we just want to take every single restaurant that we have in our database, and we want to annotate that restaurant with whether or not it is an Italian restaurant. So if we go to models.py and we go to the restaurant model, you can see we have all of these different types of restaurants that are defined in a type choices class, and for the restaurant type field we are adding those choices here at the right hand side, and that means that a restaurant can be any one of these restaurants. What we're going to do is annotate every single restaurant that we're getting back from the database with a simple boolean output field that tells us whether or not the restaurant is Italian. Now we can use the case and when objects to do this. We can use these conditional expressions. So let's see how to do that now. So we're going to get back a set of restaurants. We're going to store that in a variable called restaurant, and it's going to be restaurant.objects.annotate. And we're going to annotate the query set, and we're going to add a boolean field. Let's give that field a name of isItalian, and we're going to set that equal to a case expression, a conditional expression in Django. Now in order to do this, we're going to use the case object, which we need to import at the top here from the Django models module. So let's import that, and we're also going to use another object called when. Now as we mentioned in the intro, the case object here, this encapsulates the condition, and we use the when object to actually define the logic of the condition, and that's going to be this if-else logic that we can use within the ORM statement. So let's see exactly how to do this. In the case object, we're going to define a when object, and we're going to use the restaurant type field, and we're going to check if that is equal to this Italian type that we've pulled out on line 8. Now this statement will either evaluate to true or false. If it evaluates to true, then we can pass in the keyword argument of then, and this will define the value that's coming back from the database if this condition is true. So if the restaurant type is Italian, we're going to return true in that case. Now when you're using these case objects, you can also define a default. That's what we're going to do at the end here. We're going to define a default value of false. So whenever we have a restaurant whose restaurant type is not equal to Italian, the default value is going to be fired in that case, and that's going to be false. Otherwise we're going to get back true here. Now we can define as many when objects as we want within the case expression, and we're going to see examples of that very soon. But once we've done this annotation, we will have a field called isItalian on our restaurants. So what we can do here is print these out. I'm going to use the print statement here, and we're going to print out restaurants.filter, and we're going to filter down these restaurants to the ones where the isItalian field is equal to true. So let's run this script on the terminal with the python manage.py run script command, and the name of the script is ORM script. This should now return the Italian restaurants to us, and you can see the restaurants that are printed out here. These are all Italian restaurants that are coming back from the database. So let's go over what's going on here. What we're doing is we're pulling out the Italian type, and we're annotating every single restaurant in the database with a field called isItalian, and that annotated value is the result of a conditional expression which we define with the case object in Django, and inside that case object we're passing these when objects that define the logic of the conditions. So in this case we check if the restaurant type is Italian. If it is, we're going to annotate that value with true, and we have no further when objects, so the default will then fire if it's not an Italian restaurant and set this annotation to false. We then print these out to the terminal, and we can use that annotated field in order to get back the values that we want. So this is how to use, in a very simple way, a conditional expression in Django to check a particular condition in the database and define a value in the case that that is true. And very quickly before we move on, let's check the connection.queries by uncommenting that, and we can see the SQL that is executed in the database in order to generate this output that we see here. So if we look at the SQL statement, you can see the select statement is selecting all of these different fields, but we have this expression here, the case when expression, and within that we are checking the restaurant type. If it is equal to Italian, then we are returning 1. Otherwise, with this else statement, we are returning 0. And then we end that case expression and we alias the resulting value with the 𝗏𝐻𝐸Talian value that we have put into the annotate method, as you can see up here. So that's one example of how to use these conditional expressions in Django. Let's remove this code here and we're going to bring in some new code instead. Let's say that we wanted to annotate each restaurant with a boolean that indicates whether or not it had more than 8 sales in the database. So let's define a statement here. It's going to be restaurant.objects.annotate, and let's start by just annotating with a value number of sales, which we're going to set equal to the count aggregation function over the sales. And if we look at models.py, we have this sale model that has a foreign key to restaurants, and the related name for that foreign key is sales. So when we are querying over the restaurants here, we can look at that reverse relationship and get back all of the sales by using this field, and then we can aggregate using this count function in this case over all of those sales. So that will annotate each restaurant with its number of sales in the database, and we can get just those values back using the .values function. So we're going to print out this statement and see what kind of values we're getting back for these restaurants. So let's execute this script and we're going to see the output that we're getting at the bottom here. We have this query set coming back. It just contains this new n sales value, and you can see that there's values from 3 up to 10 here, and in fact we have one restaurant with 11 sales, so the values are between 3 and 11. Let's now add another annotated field here called 𝗏𝗶𝗶𝗹, and we're going to set that to true if the restaurant has more than 8 sales in the database. So let's go back to our query here. Now what I'm going to do is remove this print statement and store the results of this query in a variable called restaurants. And we can also remove the call to .values. We're just going to annotate each restaurant with the number of sales. Once we've done that, we can then perform a further query. So it's going to be restaurants here. We're going to redefine the variable, and we're going to set that equal to restaurants.annotate. And the annotated field this time is going to be called 𝗏𝗶𝗶𝗹, and again we're going to set that to a conditional expression here. So let's define our when statement here for the logic of this expression. We're going to check if the number of sales is greater than 8, and if that is true, what we're going to do is we're going to return the boolean value true here, and we can define again a default of false in this case. So this is a little bit more complex than the previous example. We're annotating every restaurant with a value indicating the number of sales, and then we're performing a further annotation here where we use a conditional expression over the previously annotated value to check whether it's greater than a particular number, and set a returned value, a conditional value, based on whether that's true or false. So what I'm going to do now is I'm going to print out another statement here. We're going to print out restaurants.values, and let's take the two annotated values here. We're going to print out the number of sales, and we also want to print out the new value, which is 𝗏𝗶𝗶𝗹. So let's again rerun the script at the bottom, and we're going to bring this up here, and you can see that for restaurants whose number of sales is less than or equal to 8, the 𝗏𝗏𝗶𝗹 field is set to false, but if it's greater than 8, in this case it's 9, it's set to true. So we are annotating every single restaurant that we're getting back from our query set here with the number of sales that that restaurant has in the related table of sales, and then we're taking that annotated value and we're performing a further annotation to check whether or not it's a popular restaurant, and we define that boundary at 8. And just like before, we can then use the annotated value in a filter expression. So let's go down here, and what we're going to print out here is restaurants.filter, and we're going to only get back the restaurants where 𝗏𝗶𝗶𝗹 is equal to true. So let's run the query at the bottom, and we can see the output there, and those are the restaurants that have more than 8 sales and are therefore deemed as popular restaurants in the system. Now, as I said earlier, we can actually pass multiple conditions to the case object that encapsulates these conditional expressions. So what I'm going to do is remove all of this code here. We don't need any of that anymore. And we're going to start by defining a new problem here, and we're going to write these conditional expressions to solve the problem. So I'm going to write a comment at the top here, and these are the conditions that we're going to look for here. Let's imagine that what we want to do is find all restaurants who have a good average rating. in this case a rating of greater than 3.5. But we also want to check that the restaurant has more than one rating in the database. So why might you want to do this in this imaginary system? Well, you might have one person who has rated the restaurant 5 out of 5. That might be the owner of that restaurant, but that doesn't necessarily mean that the restaurant is good. It's just one single person who's given it that rating. So we might want to add a conditional check here to make sure that more than one or more than X number of ratings have been added for that restaurant. So let's start by annotating each restaurant with the average rating and also the total number of ratings for that restaurant. So let's define a variable called restaurants, and we're going to use the restaurant.objects.annotate function, and we're going to annotate each restaurant with two new fields. First of all, the average rating, and we'll use the average aggregation function. And for each restaurant, we have the ability to look at the ratings. That's a reverse foreign key. If we go to models.py and we look at the rating model, there is a foreign key from that model to the restaurant, and that has this related name at the right hand side of ratings. So we can use that related name here and get the average over the ratings, but we also need to follow the reference to the rating and access its actual numerical field called rating, and that refers to this field here, which is a positive small integer field. So just to make that clear, we're looking at the restaurant model, we're following the foreign key to all of the associated ratings, and we're looking at the rating field here for each one of those and then calculating the average of those ratings. And as well as the average, we also want to get the count, the number of ratings that have been associated with that restaurant. So we'll add another annotated field called num ratings, and we're going to set that equal to the count aggregation function. And again, we're going to look at the ratings that we have associated with this restaurant. And if we want to get all the unique ratings, we can just look at the primary key of those associated ratings. So that's the restaurants. Let's print out the values of those annotated fields using the .values function, and the fields are called average and num ratings. So we're going to print those out and look at the terminal at the bottom. So let's see the output that we're getting here. We have average ratings, for example 5 from 4 ratings, 1.5 from 2 ratings, and so on. And we also have a few values here. We have 1 equal to none because there are no ratings for that particular restaurant. Now if you don't want none values in your aggregation functions, check out the last video that we did on handling null values and the coalesce function in Django. But for now, we're going to keep going with this example. We have the restaurants and we have annotated each one with its average rating as well as the number of ratings that it has in the database. What we now want to do is perform another annotation, and we're going to add a field that's conditional to each restaurant, and that value is going to be true for the condition if the rating or the average rating is greater than 3.5 and the restaurant has more than one rating. So let's remove the print call here to restaurant.values, and what we're going to do is we're going to use the restaurants that we defined above, and we're going to use another annotation here by calling the annotate function, and our annotation this time is going to be called highly rated, and we're going to set that equal to another case expression in Django. So this time we're going to create a when object, but we're actually going to pass two different conditions to that object. And you can see from the IntelliSense here on Visual Studio Code that it can take as many conditions as you want, and then it has this then keyword argument that we set after those conditions. So what we're going to do is we're going to specify the conditions here. We want the average to be greater than 3.5. So if it's a highly rated restaurant, it must have an average rating of greater than 3.5. And let's now pass that second condition. We're going to look at the number of ratings, which was one of the other annotated fields, and we're going to check that we have more than one rating in the database for the restaurant. And if both of those conditions evaluate to true, we can set the returned value to true as well by using the then keyword argument. So that's our when condition, and again we can specify a default of false. So if these conditions don't evaluate to true, the highly rated annotation is going to be set to false. Otherwise we'll set it to true. And once we've done that, I'm going to use a print statement here, and we're going to look at the restaurants that we have, and we're going to use the .filter function in Django, and we're going to look at that annotated field of highly rated, and we're going to look only for those restaurants where that value is set to true. So let's execute the query on the terminal below, and you can see we get back these restaurants. Now these restaurants must all match the two conditions that we specified. The average rating must be greater than 3.5, and the restaurants must have more than one rating in the database, and in that case we get back the highly rated annotation set to true, and then we can filter that as we're doing below here. So this example has highlighted that we can pass multiple conditions into the when object in Django, and the then statement here, which will return a particular value, will only be executed, or it will only set the value to that if all of those conditions evaluate to true. Now what we can also do, as I said earlier, is we can pass multiple when objects into this case object here. So let's see an example of that now. Rather than just checking if it's a highly rated restaurant, we're going to filter the restaurants into different buckets here, and let's call this rating bucket in this case. And what I'm going to do is I'm going to change the code that's in the when object here. So we're going to create 3 different buckets here in our application. A restaurant can either be highly rated, it can have an average rating, or it can have a bad rating. So let's start with the bucket for highly rated restaurants. We can look at the average annotation that we got above, and we can check if it's greater than 3.5. And if that's true, we can set the then value, and instead of just a boolean as we've been doing up until now, I'm going to set a raw value here by importing the value object from Django's models, and then we can go back down to this statement and we can instantiate a value object, and we can pass in a string to that, and the string I'm going to pass in is highly rated. So that's the bucket for highly rated restaurants. They will have an average rating that's greater than 3.5. I'm going to copy this line down below, and we're going to define a second when object here, and this is for restaurants with an average rating. So I'm going to change the value of the then expression to average rating, and what we need to do now is define the conditions for which a restaurant will have an average rating. So again, we're going to look at the average field, but instead of greater than, I'm going to use the range lookup here, and we're going to look for restaurants whose average rating is between 2 values, and the values are 2.5 and 3.5. And the range lookup in Django, we've covered that before, but I will mention now that that is inclusive, so it will include all restaurants who have an average rating of 2.5 and also any restaurants that have an average rating of 3.5. So this is inclusive, so we're not going to get any overlap between this and the one above, where we're only looking for restaurants that have an average rating that's greater than 3.5. So in our rating bucket conditional expression here, we have 2 conditions, 2 when objects, and also a default. Let's add a third when object just below here, and this is for restaurants who have a bad rating. So I'm going to change the value that's returned here to bad rating. And finally, we can change the lookup as well. We're going to look for restaurants who have a rating, an average rating of less than 2.5, and any restaurants that match that condition should have this annotated field return a value of bad rating. So I hope that makes sense. We can then use this annotation within any further expressions in the ORM. So I'm going to use the restaurants.filter statement that we have here, and I'm going to pass in that new annotated field here. We're going to look for restaurants whose rating bucket is equal to highly rated. Now we're using some magic strings here. You might want to factor these into an enum or a similar data structure, but we're just going to do this for now. Let's execute this query, and we're going to see what restaurants are highly rated. And we're getting this error at the bottom here, and that is that we have an expression that contains mixed types, the char field and the boolean field. So what we have here, we have a problem, and that's because I've left the default value in this expression. We don't need that because these conditions will cover all possibilities. We either have a restaurant whose average is less than 2.5, or we have restaurants whose average is greater than 3.5, or we have restaurants that are somewhere in between those values. We don't need the default, and the problem there was we were setting the default to false, whereas all of the others in these when conditions, these were returning strings or char fields, and we shouldn't mix those types when we're using these conditional expressions. So let's now try and re-execute this query now that we've removed the default, and you can see we're getting back all of these restaurants that have the high rating or the average rating of greater than 3.5. If we look at the restaurants who have a bad rating, we can look at this value here and paste that into this rating bucket filter, and then when we re-execute this, we're going to get back a different set of restaurants this time, and these are the restaurants whose average rating should be below 2.5. Let's now move on and show another example. Now we can use Q objects, which we saw in a previous video, within these when expressions. So again, I'm just going to remove most of this code for now, and I've left a comment now at the top here for what we now want to achieve. We want to assign a continent to each restaurant in the database. And the continent is going to be based on the restaurant type field. So let's scroll up to the restaurant model. We have these different restaurant types, for example, Indian, Chinese, Italian, and so on. What we want to do here is we want to assign a continent to each of those based on the type. A bit of a contrived example, but it's going to show quite a useful concept here in Django, how we can achieve this. So for example, Indian and Chinese would have the continent of Asia, and Italian and Greek would have Europe. So let's go back to the script and we're going to write the code for this just now. Again, we're going to use the restaurant's annotate method, and the annotation here that we're going to add is for the continent, and we're going to set that to a conditional expression using the case object. And we're going to define multiple conditions here. So the first one is going to be a when expression that's going to check if the restaurant is an Italian restaurant or a Greek restaurant. And if it's one of those, it's going to assign the value of Europe to this continent. So what I'm going to do in order to do that is I'm going to import the Q object, and that's because we need to perform an OR query here. So let's go back to the when object, and we're going to define a couple of Q expressions within that. We're going to look at the restaurant type, and we're going to check if that is equal to Italian. Now, in order to check this, just to make this a little bit easier, I'm going to get a reference to these type choices within the script here. So let's paste an expression in here where we have a variable called types that's set to that type choices class. We can then reference types like this, which is going to save me a bit of typing. And for European restaurants, we can look for the Italian type. And then, and this is the reason that we're going to use the Q objects, we can perform the OR query here. And again, we can look at restaurant type, and this time we can check if it's equal to types.Greek. So if the restaurant's one of those two types, we can then use the then keyword argument and set the value equal to this value object and pass in Europe here. So in order to make this a bit clearer, I'm going to close the sidebar on VS Code, so we can see that we are checking if the restaurant is Italian or if it's Greek, and if it's true, if that value is to true, we're setting the return value here to Europe. So let's now add another when expression below. We're going to check for Indian restaurants here and Chinese restaurants in the second when expression. And if one of those two evaluates to true, what we're going to do is we're going to set the value to Asia. And if we go back to models.py, as well as these types, we also have Mexican, which we're going to look for now. So let's copy this when expression down below. We don't need an OR statement here because we're just checking for a single value. So we can actually remove the Q object from this expression, and we're just going to check if it's equal to Mexican. And if that's true, the continent is going to be North America. And we have a couple of other types in this type choices class. We have fast food and other. Now these don't have a continent associated with them. So what I'm going to do is define a default value here. And I'm going to set that to the value of not available. So I hope that makes sense. We have this statement here looking at the restaurants and annotating each restaurant with a continent. And we're using multiple when objects in Django within this conditional expression to set the value to Europe, Asia, North America, or not available. So we can then use this annotation in the Django filter statement. So what I'm going to do is print out again restaurants.filter. And let's say that we wanted to get all restaurants who had an Asian cuisine. We can look at the continent and set that equal to Asia. And then when we execute the script at the bottom, that should now return to us the Asian restaurants. So we have these Indian restaurants here, and we also have Chinese restaurants. So that seems to have worked. And if we look at European restaurants and execute this script again, we should get back this time the European restaurants. And these are just the Italian ones. I don't think there are any Greek restaurants in the database. But this shows how we can annotate a particular model in Django and the rows that are returned from the database with a useful value that uses conditional expressions to check a particular value and then returns a value based on whether those expressions are true or false. Now what I'm going to do now is rewrite this query to something that is much cleaner to read as a developer, and that's very important, and it's one of the benefits of using these Q objects in Django. So in order to do that, I'm going to copy these Q expressions out of the when object, and I'm going to define a few variables just above this expression. Now to start with, I'm going to define European as a variable here, and we're going to set that equal to this Q expression where we're checking if it's Italian or if it's Greek. And then we can pass that in here, and that is going to be referenced as European, and that's much cleaner to read in this case, in my opinion. And we can do the same for the other values as well. So let's pull out the Asian values, and we can store that in a variable called Asian. And again, we can reference that below. And we can do the same for the North American restaurant types here. In this case, we don't have a Q object. We're just looking at the restaurant type and checking if it's Mexican. I'm going to cut that out of there, and at the top we can define that variable of North American, and we can set that equal to a Q object and paste that condition in there, and then we can reference again North American within the when object. And I think that this statement is a bit cleaner than it was before, and that's because we've extracted the filters into dedicated objects, Q objects, and then we reference those within the when objects, and that's much cleaner to read in my opinion. Now I want to finish with a more complicated example, so I'm going to remove all of this code that we have here. What we want to try and do using when objects is aggregate the total sales over a 10-day period for each restaurant, starting from the first sale up until the last. So in other words, we want to aggregate all sales from the 1st to the 10th of the month, and then we also want to do the same for the 11th till the 20th and so on. So we're aggregating all of the sales in the database over 10-day windows. Let's see how we can achieve that using these when expressions. So what I'm going to do is define two variables here, first sale and last sale, and I'm going to import the min and max aggregations from Django at the top here. And what we're doing just below here is we're getting the date of the first sale by looking at the minimum over the date time column in the sale table, and we're doing the same for the date time column, and we're looking at the maximum to get the last sale date. So we have the first sale and the last sale, the dates for those, and now we want to calculate aggregations over the sales in 10-day windows between the first sale up until the last sale. So let's clear the terminal. I'm going to make that a little bit smaller while we write this code. So what we're going to do now is we're going to generate a list of dates that are each 10 days apart, and we're going to start from the date of the first sale. So what I'm going to do at the top is I'm actually going to import Python's itertools module just to show this example in a way that we might not have seen before. And I'm going to create an empty list for the dates that we have in the database, and I'm going to use the itertools.count function to create a counter essentially. That returns an iterator that we can progress infinitely by calling the next function. So to start with, it'll be equal to 0, and then it will be set to 1 when we call next again, and then 2, and so on. What we're now going to do is we're going to try and populate this list of dates with a set of dates that starts at the date of the first sale and then progresses in 10-day increments after that. So in order to populate that list, I'm going to create a while loop here, and we're going to create a variable called dt using Python's walrus operator, and we're going to look at the first sale that we have here, and we're going to add to that a timezone.time delta. And what we're going to add is the time delta here, is we're going to set this equal to a number of days, and that's going to be 10 multiplied by calling the next function over that count. And we're going to continue this loop while that resulting value is less than or equal to the date of the last sale. So I'm just going to write the logic. It's a simple append statement here where we're appending the date that we get back from this expression here to the list of dates that we have above. So what's happening here is we're setting a variable called dt, and that's going to be equal to the date of the first sale plus a time delta of 10 multiplied by whatever the count variable is at the given time. And the first time that that while loop runs, the count variable will be set to 0 when we call next, so it's going to evaluate to 0 here and just add the date of the first sale to that list. And the second time that the loop runs, the value after calling next is going to be 1, so 10 multiplied by 1 will evaluate to 10, so we're adding 10 days to the date of the first sale. And then the next time that the loop runs, the value of count is going to be 2 after calling next, and 10 multiplied by 2 is going to be 20. So each time that this loop runs, we are adding 10 days to the date of the first sale, and then it runs again and we add another 10 days. So we're generating these 10-day windows. And I think the easiest way to see that is to print these dates that we have in the final list to the terminal. So let's print them to the terminal and run this script here with the run script command. And you can see the dates that are generated. It starts on the 20th of June, and the next date is the 30th of June, and then we go to the 10th of July, 20th of July, and so on. So what we have here is 10 datetime objects that are spaced 10 days apart. What we're going to do now is we're going to write a conditional expression here, and we're going to get the total income of all sales that were made between those date times. So if we quickly go to models.py and go to the bottom here, we have a sale model that contains an income field. So we want to sum up the incomes of all sales that fall between each of these windows. So for example, the first and the second date, we want to get all of the sales that fall between those dates and then sum up the incomes. And then we want to move on to the second and the third date times that we have in this list and sum those up as well. So I hope that makes sense. if we go back to the script, we can start writing the code that's going to use these dates, and it's going to generate multiple when objects from these dates. So let's clear the print statement and let's get started writing this code. So now that we have the dates, what I'm going to do is for each one of these dates, I'm going to create multiple when objects. So let's create a variable here called whens, and that's going to be a list comprehension in Python. And we're going to create a when object for every single element in that dates list. And these conditional expressions are going to be applied to sale objects, which each have a datetime field. And we're going to use the range lookup here, and we're going to pass in a particular value dt that we're going to get from the for loop. And we're going to also add a timezone.time delta of 10 days to that particular date object. So we set days equal to 10 here. And don't worry if this doesn't make sense, hopefully it will after we finish writing the code. We're checking if the date time is in that range between a particular starting date and the date 10 days ahead of that starting date. And if that evaluates to true, we're going to create a then keyword argument here. And we're going to use the value object that we saw earlier, and we're going to take that date and use its .date function and set the returned value to that date. And we're going to do that for every date that we have in the dates list that was defined up here. So just to summarize, for every single date that we have in the populated list of dates that are 10 days apart, we're going to create a when object for every single one of those dates that takes that date and also the date 10 days in the future. And we're using the range lookup here, and we need to add the equal sign here actually. We're using the range lookup to check if the sale is going to fall between those two dates, and if it does, we will return that date as the annotated value. So that's our list of when objects. We can then add them to the case statement one at a time, but we can also pack them in one statement. So I'm going to create a variable called case here and instantiate the case object that we have in Django and unpack all of the whens that we've populated above in that list here. And we can also set an output field, and I'm going to set the output field to a Django car field, and we need to import that at the top. Just from the models module here, let's import the car field, and that's going to be the output type for the result of this case expression. So I know this is quite complicated, but hopefully it makes a bit of sense. If not, we can go through it here at the end. What we're finally going to do, and this is the last line of code in this video, is we're going to use the sale.objects.annotate function. And let's add an annotated field here of date range, and we're going to set that equal to this case expression that we had above. We're then going to get the values that we're getting back from that date range, from that conditional expression, and then finally we can call the .annotate method and we can sum up the total sales here. We're going to create an annotated field called total sales and use the sum aggregation function over that income field on the sale model. So let's import the sum function at the top here, and then we can go through this example one last time to see that it makes sense. And let's print the result of this expression to the terminal, and we can see the output that we're getting here. So let's execute the script at the bottom, and I'm going to bring this up so we can see the output. We have a bunch of date ranges, and we also have the total sales that were made between those dates. So for the date range that starts on the 20th of July, we have a total number of sales here, a total income of 1,315. And for the date range that starts on the 30th of July, we have a total of 912. So what we're doing here is for each 10-day window, we're calculating the total income that was generated in those 10 days from sales that were made at that time period, and we're displaying them in this case just on the terminal. So let's walk through this code one last time to understand what's going on a little bit better. It's quite a complex example. What we're doing at the top is we're pulling out the first and the last sale dates from the database, and then we're creating an empty list of dates here, and then we're calling itertools.count to get back this infinite iterator that we can use within the while loop below. Within the while loop, we are creating a variable called dt, and this represents each date at each iteration of the while loop, and this works by looking at the date of the first sale and adding a time delta that's dependent on what iteration we're on in the loop. And each time the loop iterates, it calls the next function on this counter object from itertools. So that goes from 0 to 1 to 2 and so on, and we're adding 10-day increments to that first sale at each step. So at each step we have a particular date object, and while that is less than or equal to the date of the last sale that we pulled out from the database, what we're doing is appending that date to our empty container that we created above, and then we have, after that while loop, a list of populated dates. What we can then do is, and what we are doing, is we're creating another list of when objects in Django. And these when objects are going to be applied to the sale field in the sale.objects.annotate function, and they're looking at the sales datetime field that captures when the sale was made. And for each date in the list of dates, what we're doing is we're checking if the sales datetime falls between that date and 10 days into the future, and if that evaluates to true, we're returning the value of that date as the annotated field. So for every 10-day window, we create a when object that's going to check for sales being within that window, and then we create the case expression below. We unpack all of these when objects within the case expression, and we define that the output field should be a car field, and that's because the value coming back, it's a date object, but we want it to be represented as a string, and that string is shown below on the terminal. You can see that here, for example, for this date range, it's shown as a string here. And the final part of this whole puzzle here is the sale.objects.annotate function. We're passing our case expression here to that annotate function, and we're creating an annotated field called date range. We're then getting the values from that date range and annotating over them again to create the total sales for that particular range. And the total sales is simply generated by calling the sum aggregation function over the income field of the sale model. So it's quite a lot to take in. This is more complex than the other examples, but it demonstrates how we can create a list of dates in this case, and then create a list comprehension that populates a bunch of when expressions that can then be used within the database to check if a particular row has a value that falls between multiple conditions, and return the correct value based on those conditions. And this can be good for performing aggregations in buckets, in this case over a 10-day window. So that's all for this video. We've looked at conditional expressions in Django, we've looked at the case and when objects that can be used to build up these expressions, and we've looked at multiple examples of how these are used in Django. If you've enjoyed this video, please like and subscribe to the channel, and if you want to support the channel, we have a Ko-fi link in the description. Otherwise, thank you very much for watching, and we'll see you in the next video.